Welcome, dear students, to another very interesting topic, that is the resonance structures of ozone. Ozone is an allotropic form of oxygen. Oxygen is naturally present in two forms. One is O2, which is molecular oxygen, and that is the oxygen that we inhale through breathing. And the other one is O3, which is ozone, and this ozone is naturally present in the stratosphere to protect us from the ultraviolet radiations. Oxygen atom in ozone is sp2 hybridized. The overall geometry of ozone is bent or V-shaped, just like the geometry of water. And this bent or V-shaped geometry of ozone is due to presence of lone pair of electrons on the central oxygen atom. The bond angle is 116 degree, and oxygen, it is a member of group 6A, or in modern periodic table you can say group 16. As it is a member of the group 6A, so it must have 6 valence electrons in it. Now let us calculate the total number of valence electrons in ozone. Ozone consists of 3 oxygen atoms. One oxygen has 6 valence electron, again other has 6 valence electron, so 6 plus 6 12, and the 6 valence electrons of the third oxygen, when they will be added, then there will be total 18 valence electrons in ozone. Now let us look into the proposed structures of the ozone. According to the proposed structure, it says that there is a central oxygen which is attached to two peripheral oxygen, one through the double bond and with other through the single bond. Now let us look at the octet of these three oxygen atoms, how their octet is completed. This oxygen has one bond pair of electrons with this oxygen. If it has two electrons in the form of the bond pair, then to complete its octet, it must have 6 electrons in the form of the lone pairs. So it has 3 lone pairs of electrons, and hence 1, 2, 3, 4, 5, 6, 7, 8. It has total 8 electrons in its valence shell, and its octet is completed. 2 electrons in the form of bond pair and 6 electrons in the form of 3 lone pairs. Now this central oxygen has one bond pair here, and it has two bond pairs with this oxygen. So there are total 6 electrons in the form of 3 bond pairs. So it must have only one lone pair to complete its octet. Now this oxygen, it has two bond pair of electrons, and to complete its octet, it must have two lone pair of electrons. 1, 2, 3, 4, 5, 6, 7, 8. Its octet will be completed in the form of two bond pair and two lone pair of electrons. Now, dear students, the oxygen which has formed more than two bonds, it carries positive charge, and the oxygen which forms less than two bonds, it carries the negative charge. So this one is the first proposed structure of the ozone. Now, dear students, the negative charge of this oxygen can move here, and it can convert this single bond into double bond, and similarly, one bond from this that can be converted to this oxygen atom, mean one bond pair will be given to this oxygen atom, and the double bond will be changed to the single bond. So the next proposed structure should be single bond, and it should be double bond, and there should be same electronic arrangement, one bond pair and 3 lone pairs, 2 bond pairs and 2 lone pairs, 3 bond pairs and 1 lone pair, and again it should carry positive charge, and now it should carry negative charge. This one is the second proposed structure of the ozone, and there are only two proposed structures which are possible for the ozone. These two structures are called as the resonance structures or canonical forms of ozone. Resonance structures are also called as the canonical forms, and they must be connected through a double-headed arrow, which is a symbol of resonance. Resonance is basically the existence of a compound in more than one structures, in more than one forms, that is called as the resonance. And the structures that arise because of the resonance, they are called as the resonance structures. In resonance structures, you will find equal number of atoms, equal number of bonds. Here two bond and this one is a single bond, so total there are three bonds, and again in this structure there are total three bonds. There is same position of the nuclei, and there are same number of the bonding and non-bonding electrons or lone pair of the electrons. So these two structures, they are called as the resonance structures. And keep in mind that resonance structures do not have any actual existence. They are just theoretical proposed structures. As they do not have any actual existence, so they are never interconverted into each other. There is no dynamic equilibrium between these two structures, just like the dynamic equilibrium we see in the tautomers, because tautomers have actual existence. And now let us look at the data these two structures provide. The bond length of oxygen-oxygen double bond should be 121 picometer, and the bond length of oxygen-oxygen single bond should be 148 picometer. So these structures, they show that in ozone there must be two types of the bond lengths. One should be 121 and the second should be 148. Now let us evaluate the structure of the ozone experimentally, whether these structures, they do resemble with the experimental information or not. When we evaluated the structure of the ozone experimentally, then the experimental bond length in the ozone, that was neither 121 nor 148, it was 128 picometer. It means that these structures, they provide exact geometry of the ozone, that is bent or V shape. They also provide the bond angle of the ozone, that is 116 degree. They are also providing the correct information about the number of bonding and lone pair of the electrons, but they are not providing the exact information about the oxygen-oxygen bond length. According to these proposed structures, there should be two types of the bond lengths, but experimentally we have found that there is only one bond length in the ozone, and that is 128 picometer. So the actual structure of ozone should be something like that. It should be having bent geometry. The angle should be 116, just like these two resonance structures. But in order to justify the bond length is neither equal to the double bond length or the single bond length, it is in between the bond length of the oxygen-oxygen double bond and oxygen-oxygen single bond. So in ozone, the bonds are neither double nor they are single, but they are something in between them. So one bond is shown with the solid line, other bond is shown with the broken line. This solid line shows complete bond, while this broken line shows half bond. So the bond order is neither 2 or 1, rather the bond order of both these bonds is 1.5. And because the bond order is 1.5, it is neither two bonds nor a single bond. So the bond length should be in between the bond length of the oxygen-oxygen double bond and oxygen-oxygen single bond, that is 128 picometer. It is neither 121 nor it is 148. Now this structure, which is derived from these two structures, that is called as the resonance hybrid structure. This resonance hybrid is basically the hybrid of these two resonance structures, and this is the structure which is closest to the actual structure of the ozone. It is closest to the experimentally determined data of the ozone. Now, this resonance hybrid, it is always more stable as compared to its canonical forms, because the resonance hybrid is present at the lower energy state than its canonical forms. And dear students, keep in mind that greater the resonance structures of any substance, higher will be its stability. Ozone has two resonance structures, but there are some molecules that have three resonance structures. Benzene has five resonance structures. So greater the resonance structures of a substance means it is highly stable one. So that was about the resonance structures of the ozone. Next time we will come up with the resonance structures of carbonate ions and carbon dioxide. Till then, take care.